Standard form is a very simple calculating system that helps us to deal with very big or very small numbers. We actually use it in many different ways, and I'll just try and give you an introduction to that now. And fortunately as well, it's on your calculator and it makes our lives very easy. Let's look at some basics before we move directly into the standard form. If we had 10 squared, that means 10 times 10. And as you know, that means 100. So if we had 10 cubed, 10 to the power 3, that is 10 times 10 times 10, which is 1,000. This is crucial to us when we use standard form, and it will become apparent very shortly. If I were to just go back one and say 10 to the power 1, that's just 10, which is 10. So we're not going to use true standard form, we're doing standard form for engineering. And we need our numbers to be in groups of 3, which is where this comes in. Okay, let me just develop that a tiny little bit further. Throughout our lives, we automatically use this number and we're unaware of it. For example, I may buy a kilogram of sugar. A kilogram of sugar. This letter K means 1,000. It's 1,000 grams, or 10 to the 3 grams. In your electrical career, you may use resistance in megohms. So this letter M, the capital M, is a million. So that is 10 to the 6. When measuring, you may use millimeters. Millimeters. This lowercase m is 1 over 1,000, a thousandth, which we write as 10 to the minus 3. You may deal with even smaller numbers like microamps. That's the Greek letter mu for micro amps. And this is 1 over a million. In standard form, we would write 10 to the minus 6. So this is where we come to using standard form for engineering. We deal with our numbers in multiples of 3 to deal with the multiples that we use to express the numbers. For example, kilo, mega, milli, and micro. They relate directly to these numbers. So in engineering, in science, in electrical work, in electronics, we use these numbers in multiples of 3. So it's standard form for engineering. Let's take it just a little bit further. So let's suppose we have a very large number. Let's take there's a very large number, or a very small number. Let's say something like that. So these numbers take a long time to write out, they're annoying on the page, and we can express them in a much better way using standard form. I'll come back to those in a minute, but first of all, let's have a look at some simple examples, and I'll try and teach you a simple technique. Let's take the number 56,000. I want to rewrite this in standard form. You need to get in the habit of dealing with your numbers in chunks of 3. So where is the decimal point? At the moment the decimal point is there. We don't write it after a whole number, but I'm going to move it 3 times. 1, 2, 3. So it ends up in there. My new number is 56 times 10 to the 3, because I've moved the decimal point 3 times. Let me just jump in at this point. If we were doing true standard form, we would move the decimal point 1, 2, 3, 4, and we would have an answer of 5.6 times 10 to the 4. This is fine, but it doesn't tie in with the multiples that we use in engineering work. So we don't want to be doing this. This is the best way forward for us. Let's do another example. So example 2. Try this. I want us to rewrite this number in standard form. Working multiples of 3. Here's your decimal point. 1, 2, 3. And that leaves me that whole number of 750. 750. 750 times 10 to the 3. Let's pick up another one. So let's have 47. Here's the number. Move the decimal point in chunks of 3. 1, 2, 3. 1, 2, 3. Or if you prefer, 1, 2, 3, 4, 5, 6. And my new decimal point is going to go in there. My answer is 4.7 times 10 to the 6. Okay, with that in mind, let's just go back to this that I wrote at the start, and we could go from there. We can go 1, 2, 3, 4, 5, 6, and that makes this number 47 times 10 to the 6. Right, so let's have a look at some numbers that are smaller than 1. These were all big numbers, much greater than 1. Let's deal with numbers which are much smaller than 1. So, number 1, how about 0.027? We're now going to move the decimal point, or count the other way from the decimal point. So we're going to go back from there. 1, 2, 3, and my new decimal point is going to sit after the 7. So my number is going to be 27 times 10 to the minus 3. Numbers which are less than 1 will have a minus index. Excuse me. Number 2. 0.0052. Let's do it again. Move back 1, 2, 3, and my new decimal point will sit between the 5 and the 2. 5.2 times 10 to the minus 3. One more. 0 point. So 0.000063. Let's move the decimal point and we'll go back 1, 2, 3, 4, 5, 6. So my new decimal point sits after the 3. 63 is what we've got, times 10 to the minus, and I moved it 6 times. 6. Excuse me. 4. Last example. 0 point. There we go. So moving the decimal point, going back 1, 2, 3, 4, 5, 6. I could stop there and leave an answer of 0.75 times 10 to the minus 6. But what I'm going to do is add a 0 on and go back another 3. This 0 does not change the size of the number. And I now have 750 times 10, and we moved it back 9 times, so times 10 to the minus 9. Okay, so that's a little look at some of the numbers. What I want to try and show you is how that works in calculations. Let me do a couple of simple calculations. So let's call this example 1. Let me give you a scenario. We have an overhead electric power line running at 275 kilovolts. So V equals 275 kilovolts. And the insulators holding that line have a resistance of 795 megohms. So R equals 795 megohms. Find the current that flows in the insulator. So if I ever ask you to find current, think basics, Ohm's law. So here it comes. I equals V over R equals, the voltage is 275 kV, 275, and K is times 10 to the 3. The resistance is 795 megohms, so 795 times 10 to the 6 for meg. And we then put that in our calculator and work out the answer. I'll try and show you this. If it doesn't work out, I'll do a separate video and add it in later. So 275 times 10 to the 3. We want 275, this is the key button, times 10 to the 3. And look how the display is representing that. Divided by, the next number was 795 times 10 to the 6. 795 times 10 to the 6 equals, so we've got the answer of 0.000345 So let me write that down. That's what I think that is. But you now have another magic button at your disposal, and if you press engineering, it's just for us and standard form, eng. It changes what you see in the display, and it's moved the answer to standard form for you. 345.9 times 10 to the minus 6. That's times 10 to the minus 6, and 10 to the minus 6 is micro. So the current is, let's just round this up, 346 micro amps. Excuse me. Let me try and do one more. So example 2. So let's create a scenario. The potential difference across a resistor is 750 millivolts. So potential difference is in volts. V equals 750 millivolts. And the current flowing through it is 20 microamps. So I equals 20 microamps. Find the value of the resistor. So Ohm's law, R equals V over I. Put the numbers in. 750 milli is times 10 to the minus 3. Current is 20 micro. 20 times 10 to the minus 6. Let's see if I can show you this on the calculator. So these are the numbers we're going to deal with, and we've got 750 times 10 to minus 3 divided by 20 times 10 to minus 6 equals, and there is our answer, 37,500. If you press the engineering button, it'll do the standard form for you. 37.5 times 10 to the 3. So that's okay, but we want to use this as an appropriate multiple, so this is better written as 37.5 kiloohms. 10 to the 3 is kilo. Just want to come back, just use a few seconds. With the engineering button, if I press Eng again, it'll keep moving the decimal point. If I press Shift Eng, it goes back. Shift Eng goes back. Shift Eng. That is a very useful button for us.